Okay, so coming to model 1 of queuing theory. Kendall's notation of queuing model is very much important, guys. You need to know where what are all being placed. Okay, so I request you to kindly check that as well. Okay, yeah, model 1 usually is called a single server model. Okay, and it's Kendall's notation. Kendall is given like this: M1 bracket close. There are two dots, infinite, FIFO or FCFS. Okay, right. So the first one is for the arrivals, guys, arrival. The second M is for the service. The third one is the server, single or multiple. Infinite, that symbol is there, no? That is for the capacity of the system. Okay, and FCFS is nothing but the queue discipline. Okay, yeah. Now, initially, before going to do certain things, we'll go with some assumptions. For anything, there are some assumptions with which we'll go, not just randomly. We will start things quantitatively or analyzing things mathematically. Okay. Yeah. So first assumption is arrivals are Poisson in nature. Poisson arrival process is the first assumption. Okay. Second assumption is service time and inter-arrival time are negative exponential. Negative exponential distribution comes into picture for inter-arrival and service times. Okay. Yeah. Third one is that, as I have told you, single server, infinite capacity queue. Okay. Of course, yeah, infinite capacity, I can put it as the fourth point, guys. Fifth one is the first come, first serve. First come, first serve is the queue discipline. Okay. Yeah. So how do we calculate things here? Let me show you. Of course, do check the previous video for the derivation part of remaining other things that I have discussed there. Probably there is some interrelation between both of them. Yeah. First thing that I want to find out is what is the probability that exactly n customers are in the system. Exactly n number of customers are in the system. This is denoted by Pn. What is Pn? This is equal to lambda by mu whole power n P naught. I've derived this in the previous video. Just check that one as well. Okay. Yeah. Probability that there are n customers in the system is denoted by Pn, and it is nothing but rho power n into P naught. Coming to the second point. To determine the probability, that there are no customers in the system. There are no customers in the system, or probability that the system is idle. Probability that the system is idle. System is idle. No customers in the system is same as the system being idle. Okay. What's that probability is? Usually sum of all probabilities. Pn is equal to 1. All of us know. Okay. So it is nothing but P0 plus P1 plus and so on plus Pn and so on is equal to 1. Okay. Now, as I have discussed prior, I've told you for n is equal to 1, it is lambda by mu power 1 into P0. See here, I'll just try it. For n is equal to 1, P1 is equal to lambda by mu P0. P2 is equal to lambda square by mu square P0 kind of things. Okay, P2 this is. So if I substitute the same recurrence relation kind of thing in this sum of all probabilities formula, I'll have P0 plus lambda by mu P0 plus lambda by mu whole squared P0 and so on plus lambda by n whole power n P0 plus and so on. This is equal to 1. If I have taken P0, this is derivation is there. How Pn is equal to lambda by mu whole power n into P0. It's there in the previous video. Do check that. Okay. Yeah. So if I take P0 common, what I'll have will be 1 plus 1 by mu plus 1 plus lambda by mu plus lambda by mu whole squared and so on is what I have, which is an infinite one. Okay. So I know that it is something like 1 plus r squared plus and so on kind, whose formula is a by 1 minus r. So from the geometric series, sum of infinite terms. So 1 by 1 minus r is lambda by mu here. This is equal to 1. Hence, by rearranging, first I will take the LCM. So mu comes to the numerator. Mu minus lambda be in the denominator. Now, once I rearrange for P0, this would be nothing but mu minus lambda by mu, or which is nothing but 1 minus lambda by mu, or which is nothing but 1 minus rho. So the probability that the system is idle is 1 minus rho. Means what? Traffic intensity, total probability is 1. From 1, if I remove the traffic intensity, the remaining time would be the time for the system being idle. I mean, logically also, I can understand. It is clear kind. Okay. This is one question that can be asked, guys. Okay. This is how, of course, you need not remember the derivation part. You can just remember P0 is equal to 1 minus rho for the system to be idle. To probability that there are n customers in the queue is given by Pn, which is equal to lambda by mu whole power n into P0. Okay. Yeah. I'm done right now. I'll go to the third formula, which is important one in queuing theory, that is to determine, do remember this as well, to determine the probability, this is a bit confusing as well, probability that the number of customers in the system is greater than or equal to 1. Okay. This is given by P of n greater than or equal to capital N. Okay, I'm sorry. I'll write this one also as capital N only. Okay, he has given you some value and then greater than that value is asking you to find out. How do I do it? Just see, guys. I'll again build from the basics only. Small n greater than or equal to capital N. This would be nothing but summation small n is equal to capital N, sum of all the probabilities, na? Right? Okay. How do I get this? I shall rewrite. Just see here. N is equal to 0 to infinity probability of n minus n is equal to 0 to capital N Pn. Fine, na? Right? What am I talking about? See, I have the whole of probability from 0 to infinity. I mark it, I mark this point as a capital N. So if I delete this part, what I will be getting would be anything greater than or equal to capital N only. Na? If I delete this part from the total one, if I delete this small part, the thing that is greater than capital N is what I'll be getting. Okay, that's what I've written it as a formula. Right? So total probability value is 1, guys, minus this probability. How I will write? Simple. Just expand it. For n is equal to 0, n is equal to 1. Okay, n is equal to 2. And so on. N is equal to capital N. Okay. So what happens? This is again geometric series only for sum of finite terms. Sum of finite terms. I know the formula. Okay. 1 minus r power n by 1 minus r. A into, right? Okay. So 1 minus p naught 1 minus lambda by mu whole power n by 1 minus lambda by mu. Okay, of course, P naught is lambda by mu only. That also, P naught is 1 minus lambda by mu only, I'm sorry. Okay, so 1 minus lambda by mu only, this value is 1 minus lambda by mu whole power n by 1 minus lambda by mu. Okay, so what happens is 1 minus 1 minus of minus is plus lambda by mu whole power n. Hence, what it is probability that there are greater than or equal to capital N customers in the queue, customers in the system, in the system is equal to lambda by mu whole power n. Mind you guys, here I should tell you this important point. What's the difference between system and queue? See here. Okay, this is the window. Single server, let us suppose. Okay. Now, coming to this one. Okay, he's getting it served. So, this whole thing would be called system, guys. Okay, in system, there are 4 people. Okay, now queue, if you ask me how many people are there in the queue, 4 minus 1, 3 people are there because it's a single server. Since it is a single server, just a second. Since it is a single server, it is 3. Okay. So probability that there are greater than or equal to n customers in the system. So this is system, this is queue, is lambda by mu per n, guys. This is one important one again. I mean important because we get confused, not because of any other reason. We get confused when I say it's important. You need to look into it in a little more focused way. Okay, little careful way, right? Yeah. Next thing, okay. Next thing that we need is average or expected number of customers in the system to determine average number of customers in system, or this is same as expected. Expected, we know that expectation is same as average. Expected number of in the system. Okay. Number of, see here, number of people in the system. If there are no people, there is no queue. If there are people in the queue, then it becomes the length of the queue, guys. Length of queue or system, whatever. Here I'm saying system, length of system. It's also called length of system. Okay, denoted by LS. Okay, LS is equal to summation n is equal to 0 to infinity n Pn. Okay, so this is nothing but 0 into P naught plus 1 into P1 plus and so on plus n into Pn plus and so on. Again, infinite, right? Yeah. So what happens is this is 0. This is 1 into lambda by mu into P naught. I'm sorry. 2 into lambda by mu whole square P naught plus lambda by mu whole cube 3 into P naught plus and so on. It is something like your binomial expansion, guys, where you have 1 plus x plus 2x squared plus 3x cube plus and so on kind. Okay. So this would be something like 1 minus x power minus 1. Since all pluses are there, both are of the same sign. Both are negative kind. Okay. So what happens is P naught I take out. Also, lambda by mu I take out. So I'll be having something like 1 minus lambda by mu power minus 2 kind. Okay. This is minus 2. I'm sorry. Not 1. Minus 2. Okay. 1 would be no coefficients. It will be 1 plus x square kind only. Okay. 2x plus 3. 2x only this is, guys. 2x 3x squared kind. Okay. So this is the formula. Just do check the binomial expansion, guys. Hence what happens is P naught anyways I know. P naught is 1 minus lambda by mu. This is lambda by mu. And this is 1 by 1 minus lambda by mu whole square. So this one and this one gets cancelled off. Lambda by mu will be there. In the denominator, if I take the LCM, mu minus lambda by mu would be there. This mu gets cancelled and hence it is lambda by mu minus lambda. Or in other words, length of the system is nothing but, for a infinite capacity is nothing but single server. This is lambda by mu minus lambda. Okay. Yes. Now, once length of the system is done, I know how to find both are interrelated. Length of the queue I can easily find out. See here. The fifth formula is waiting time. Waiting time in the system. Time in the system. Or it is also called, I mean, why I'm telling or is depending on the terminology in the question paper, you will accordingly calculate without getting confused. Average time spent by the customer in the system. It can be asked this way as well. Or directly they'll ask you, since it is waiting time, it is just WS, waiting time in the system. Directly they can ask you to find out WS. See here, guys, what is WS? It is just LS by lambda. That's it. The ratio of length of the queue by lambda. Okay, average arrival time, right? So it is nothing but lambda by mu minus lambda by lambda. This would be 1 minus mu minus lambda. So waiting time in the system is 1 by mu minus lambda. Done? Right. Next one that we'll be doing is average number of average number of customers in the queue, as I was talking about. Once I know how to find average number of customers in the system, it is 1 less than average number of customers in the queue is 1 less than average number of customers in the system. That's it. So accordingly, we will derive. See, if you can derive and remember, it is fine. Otherwise, just remember the formula. Okay, to determine the average number of customers in the queue. Okay. Expected number of customers in the queue also you can say. That is nothing but length of the queue. Length of the queue denoted by LQ. Okay. What is LQ? Just see here, as I was telling you, 1 less than the one getting served is deleted for the queue from the system, right? So just see here, how can I write this is separate n is equal to 1 to infinity npn minus summation n is equal to 1 to infinity pn. Okay, so I can write this as summation n is equal to 0 to infinity npn. I have added extra term n is equal to 0 term, guys. See, if I have added n is equal to 0 terms, so what happens is summation n is equal to 1 to infinity pn is as it is. This extra term that I have added, I am subtracting it. Okay, so what happens? Just see here. Yeah, n is equal to 0 is included and n is equal to 0 is deleted. So what happens is, this is nothing but summation n is equal to 0 to infinity npn is nothing but ls, guys. Length of the system, guys. Yeah, minus. What's this? Summation of all the probabilities is nothing but 1, guys. Okay. Minus P naught. I know what's P naught as well. Right? So LS also I know. Let me write it below so that it's clear. This is equal to lambda by mu minus lambda is LS minus 1. And P naught is 1 minus lambda by mu. So minus of 1 minus lambda by mu. Okay. So minus of, this is plus 1 minus lambda by mu. Okay. Yeah. So is inside this. Right? Yeah. This value is lambda by, lambda by mu minus lambda. Okay. So these two get striked off. Minus lambda by mu is what remains. If I take the LCM, lambda mu minus lambda mu plus lambda squared by mu into mu minus lambda. Okay. I've subtracted. Just a second, guys. This is a separate term with a negative sign. This is a separate term with a negative sign. Okay. Yeah. So, and this value is -1 and this is like this. Okay. So it is -1 here. I'm sorry. I've just made a mess. No, this derivation is fine if you understand or not, but then there should not be errors. So I'm just correcting it. -1 minus P naught. -1 minus P naught is 1 minus lambda by mu. Okay. Yeah. Okay. Okay. So what happens? This is nothing but lambda square by mu into mu minus lambda. Mu minus lambda. What is this? This is nothing but LQ. Okay. LQ is lambda square by mu into mu minus lambda. Yeah. So coming to the final one, that is waiting time in the queue. Seventh one, that is WQ. What is that? Waiting time in the queue. Waiting time in the queue. Okay. Simple again. Once you have LS guys, everything else can be easily understood or generated. Okay. LQ by lambda. But once I have LS, WS is LS by lambda, right? So once I have LQ, WQ is WQ by lambda, okay? So lambda square by mu into mu minus lambda by lambda. So what happens is it is nothing but lambda by mu into mu minus lambda. Why I'm going with the derivation part is once you derive it, there are least chances of you getting confused. Okay. Yeah, fine. Now, finally, the final one, in case if something is being asked, what that is to determine the probability that the waiting time in the queue is greater than or equal to t. Of course, this is optional, guys. I'll write here optional. We don't have it. For a postgraduate course, this questions also can be asked to determine the probability that the waiting time in the queue, waiting time in the queue is like how I have asked the probability, similar to that. Okay. Is lambda by mu, mu minus lambda into t. Okay. This is for the queue, guys. And for the system, you see, for the system, same problem for the system greater than or equal to t. I don't have lambda by mu. I have e power minus mu minus lambda into t. Again, there's a derivation part, but that's fine. Okay. Yeah. This also has to be taken care of. Yeah. This is it. With this, I'll close this video with the formulae part. Let's do some problems for the next. Thank you.